Welcome back to the next session of transportation. Today I am going to introduce variations in transportation. Variations in transportation. We have unbalanced problem, unbalanced problems, second one degeneracy, prohibited routes. There are three variations in a transportation problem. First one is unbalanced problem, then degeneracy concept in transportation, prohibited routes concept in transportation. When total supply is not equal to total demand, total supply is not equal to total demand, then it is an unbalanced problem. Then it is an unbalanced problem. What we have to do for solving the questions, one point is very clear to us: only balanced problems are having solution. Again I am repeating this point, only balanced problems are having solution. So an unbalanced problem is first converted into a balanced problem. An unbalanced problem is first converted into a balanced problem by introducing a dummy row or a dummy column with ₹0 as transportation cost. Look at this point once again. When total supply is not equal to total demand, then it is an unbalanced problem, means unbalanced transportation problem. And everyone of we know unbalanced transportation problems have no solution. When the question is an unbalanced problem, it has no solution. So to get a solution to the given problem, what is required for us? It should be converted into a balanced problem. How can we convert this one into a balanced problem, sir? First an unbalanced problem is first converted into a balanced problem by introducing a dummy row or a dummy column. Dummy row or dummy column we are introducing from our side. Dummy row or dummy column we are introducing from our side. So we have to think what is its effect on the total transportation cost. For this answer is, per unit cost we are taking as 0. Per unit cost we are taking as 0. So 0 into any number of units, it is 0. So dummy column or dummy row has no influence on the total transportation cost. Reason is very simple. For the dummy row or a dummy column, per unit cost we are taking as 0. An unbalanced problem is first converted into a balanced problem by introducing a dummy row or a dummy column with rupees 0 as transportation cost, and consider it as real market or real factory. Dummy factory is introduced, it is treated as a real factory where we are producing the goods. If dummy market is introduced, we have to treat it as a real market and we are selling the goods in the real market. Let us see a numerical problem on this. Find the initial solution to the given transportation cost matrix. Given a transportation cost matrix, we have three factories. And how many markets are there? Three markets are there. Supply and demand. Supply and demand. Supply. Before going for supply and demand, let us consider per unit cost. 8 rupees, 5 rupees, 7 rupees, 7 rupees, 4 rupees, 5 rupees, 6 rupees, 9 rupees, and 5 rupees. Requirement at this market is 300 units. Requirement at second market is 260 units. Requirement at the third market is 180 units. Same way, supply at first market is 250 units. Supply at second market is 320 units. Supply at third market is, supply from first factory is 250 units. Supply from second factory is 320 units. Supply from third factory is 280 units. Now, see the values. Total supply. Total supply is equal to 850 units and the total demand is equal to 110 units. 740 units. 740 units. That difference is 110 units. Let's see this point once again. Total supply 250 plus 320 plus 280 is equal to 850 units. Total requirement 300, 260 and 180. 200, 260 and 180. So this is 740. Difference of this is 110. It means supply is more than the demand. Supply is more than the demand. So dummy market is required. What is required, sir? Dummy market is required because it is an unbalanced transportation problem. Okay. Look at this. Since supply exceeds demand by 110 units, introduce a dummy market with rupees 0 as per unit cost. So you have now 4 markets: market 1, market 2, market 3, market 4. As usual, 3 factories to supply the goods, F1, F2, F3. C. Supply, demand. Per unit cost is 8 rupees, 5 rupees, 7 rupees. Here it is 7 rupees, 4 rupees and 5 rupees. 6 rupees, 9 rupees and 5 rupees. Requirement in this market is, requirement at first market is 300 units. Requirement at second market is 260 units. Requirement at third market 180. Supply from first factory 250, 320, 280. Fourth market is a dummy market. Per unit cost is taken as 0. Fourth market is dummy. It is a dummy market. Here per unit cost is taken as 0, difference 110. What does it mean actually? We are assuming excess units we are selling in market 4. After converting this as a balanced transportation problem, we have to consider dummy market also real market. Let us use northwest corner rule. Northwest corner rule. Now according to northwest corner rule, you have to supply the goods from factory 1 to market 1. This point again I am repeating. When I am using northwest corner rule, I have to supply the goods from factory 1 to market 1. By doing so, a market requirement may be fully satisfied or capacity at a factory may be exhausted. 250 units are available, 300 units are required. So 250 units I am supplying here. Requirement is reduced to 50. Supply now will become 0. Supply now will become 0. We cannot supply the goods from factory 1 to any market now. So to avoid any confusion, this factory is eliminated from the picture. Now analyze the situation here. Factory 1 capacity is over, but market 1 requirement is not satisfied. I can supply the goods to market 2 only when market 1 requirement is fully satisfied, only in northwest corner rule. So these 50 units I am supplying from second factory. Now requirement of first factory will become 0. Requirement at market 1 will become 0, whereas availability reduced to 270. Availability reduced to 270. Now sir, market 1 requirement is fully satisfied. Eliminate this market from the picture. Eliminate this market from the picture. Now move to the second market. How many units are required? 260 units are required. How many units are available? 270. So 260 units are supplied to this market so that its requirement is fully satisfied. Availability now reduced to 10. From 270 units, 260 units are supplied to the second market. Now look at this. This market requirement is fully satisfied. It is eliminated from the picture. This market requirement is fully satisfied. It is eliminated from the picture. Now you can supply the goods to third market. How many units are required? At market 3, 180 units are required. How many units are available? At second factory, only 10. First 10 units are supplied from second factory to third market. So its requirement is reduced to 170. Availability F2, availability at F2 now will become 0. Now I cannot supply the goods from factory 2 to any market, so factory 2 is eliminated from the picture. Factory 2 is eliminated from the picture. Now from factory 3, first I have to supply the goods to third market, then go to the fourth market. 280 units are available at third factory. 280 units are available at third factory. 170 units are required at market 3. 170 units are supplied. So its requirement now will become 0. Here availability reduced to 110. Availability reduced to 110. Market 3 requirement is fully satisfied. It is eliminated from the picture. Now 110 units are required at fourth market. 110 units are available at third factory. 0, 0. Supply at each factory exhausted. Requirement at each market is also fully satisfied. Supply at each market is also fully satisfied. Now let us verify the conditions, sir. Number of occupied cells required. Number of occupied cells required is equal to m plus n minus 1, where m stands for number of rows. 3 rows we have. N stands for number of columns. 4 columns we have, minus 1. 6 occupied cells are required. Number of occupied cells obtained is equal to, let us see, sir, 1, 2, 3, 4, 5, 6. One more time. First row 1 occupied cell. Second row 3 occupied cells. Third row 2 occupied cells. Third row 2 occupied cells. 1, 2, 3, 4, 5, 6. So number of occupied cells obtained 6. Therefore, it is a basic feasible solution. It is a basic feasible solution. It is a basic feasible solution. Let us calculate transportation cost. Let us calculate transportation cost. 8 rupees per unit, 250 units are supplied. 5 rupees per unit cost, 50 units are supplied. 4 rupees per unit cost, 260 units are supplied. 9 rupees per unit, 10 units are supplied. 5 rupees per unit cost, 170 units are supplied. 0 per unit cost, 110 units are supplied. Okay, so this is coming out to be rupees 4340. This way, an unbalanced transportation problem can be solved in transportation. Fine, sir. Thank you for watching this video, sir. If you like my video, please subscribe my channel so that I can update more number of videos. Thank you.